Hello and welcome everybody to the course Crystal Engineering, Chemistry Beyond the Molecule. Today we will talk about supramolecular synthon. Well, I would say if you never heard anything about crystal engineering, I am sure you never heard about something about supramolecular synthon. On the other hand, supramolecular synthons are very important. This is one of the most important tools in crystal engineering. And the second topic we want to talk about is the Cambridge Crystal Structure Database. A huge database about with crystal structures. And similar to supramolecular synthon, this database is a very helpful tool for research scientific questions in crystal engineering. Okay, have a look. Supramolecular synthons, what is it? These are structural units, small, mostly very small structural units within supermolecules. You remember, supermolecules are, you can say all organic crystals are supermolecules, assemble aggregation of molecules, and with structural units can be formed and or assembled by known synthetic operations involving intermolecular interaction. Supramolecular synthons, this definition was introduced by Gautam Visiraju, you see, in 1995. Have a look. You have a molecule here, benzoic acid. This is the molecule, this is the functional group, and this is a synthon. You see it here, the combination of the molecule with the intermolecular interaction. This is the synthon here. And you can use this synthon, for example, molecular aggregation. In this case, you have two functional groups with a para position. You can use this to build up linear chains. Supramolecular synthon is a pattern that is composed of a molecular and supramolecular elements. Both together is the synthon. So not only the hydrogen bond, but both together. And an example here, carboxylic acid. See it here, carboxylic acid. You can use it, for example, here to build up linear chains, one-dimensional. You can build up layers, and in this case, you can build up three-dimensional networks. Only starting with carboxylic acid depends of her residue, what's coming out. And especially the last example here, three-dimensional network, this is a very interesting compound. This is adamantane tetracarboxylic acid. And the crystal structure was published by Ermer, 1988. This molecular structure, and you see it here. Have a look. Yeah. This is our crystal structure here, crystal packing. As I said, use it. This is really nice. You can really build up very nicely things here to learn more about crystal structure. And you see this is like here, very nicely you can see like diamond, diamond lattice. Formation of hydrogen bonds lead to a diamond lattice type. Or you can really say all organic crystal structure can be viewed as networks. So, these are first definitions, introduction of supramolecular synthons. Be sure during the lecture slides, lecture series, we very often will talk about supramolecular synthons. Finding, observing, always synthons, and how can we use it for which cases, and how can we build up crystal structure always with very defined, selected synthons. Okay, as I said, the second big topic, almost big topic, the next topic is the campus structural database. You see here an eye sketch of a database, and with a conquest, there's a possibility to search in the database. And this is really, really fascinating database. Huge amount, a lot of crystal structures you will find in this database. It is restricted on organic and organometallic crystals. You will not find the crystal structure for lithium chloride, for example. It's not possible. But if you look, if you want to find, or if you are interested in the crystal structure of lithium chloride as ephrate, yes, you will find it. And it's really a large amount, not only crystal structure, you can have a look on the crystal structure, and you will find a lot of crystallographic data and structure informations. With this very nice here picture, you see the GROW crystal chemical structure database since 1972. Here in 1965 were only 2,000 entries. 2,000, nearly nothing. We see it here, increasing numbers of crystal structures here. And this is, if you have a look on the Cambridge crystal structure homepage, you will already find here a ticker. Today, it was the 6th April this year. The daily entries were 1 million, more than 1 million crystal structure. This is fascinating, really fascinating. What is inside? From this 1 million crystal structure, more than 30% are organic. And you see the rest, nearly 60% are metal organic compounds. Nearly 60%, exactly the same like metal organic, are single component. And really amazing, I would say, more than 40% of the structure multi-component crystals. You remember something like coke crystal? I introduce this very big topic, multi-component crystals, coke crystals, and we are coming back to this very fascinating field, class of crystal structure. And you will find a lot of, for example, drugs, agrochemicals, pigments, explosives, and so on, and so on. Everything is inside. This is directly here from the homepage of a Cambridge structure database. That's really fascinating. What can you use? What can you do? You can analyze the chemical bonding, the molecular conformation. Yes. Bonding and angle situation inside the molecule conformation. When looking to the crystal packing, you can look to the intermolecular interaction, the forces between the molecules. And very interesting detailed statistical analysis of the nature of very weak interaction. Statistic, very important. If you look to weak interactions, it's always important to compare your observation with well-known crystal structure. And have a look if in the other crystal structure, well-known crystal structure, we found also weak interactions. You can look for dependencies of special selected molecules. And you can look for polymorphic forms closely related to the crystal structure prediction. You remember in the first slides, first session, I said we'll have a look on polymorphic forms and we will look on crystal structure prediction too. Well, one example. Are there typical characteristics of hydrogen bonds observable? And if yes, what are typical angles and intermolecular bond lengths of hydrogen bonds? Can you answer this question directly? I believe not. But by using the Cambridge Structure Database, you will be able to answer this question. Well, have a look here. Where is the typical strong hydrogen bond in carboxylic acid? This is called a dimer form here. Well, and this is the analysis of a lot of these compounds in the database. Here are the angles and here are the bond lengths of a hydrogen bond. What do you see? In a very near region you will see the angles, and you will see most of them are in a very near region of the bond lengths. So, see it, the angles are 160, 180 degree, OHO, and the hydrogen bond OH is between 1.6 to 1.9 to what do you want? Well, so you can say, in the case of strong hydrogen bond and carboxylic acid, there is a well-defined characteristics of strong hydrogen bond and carboxylic acids. Okay? Okay, what's going on in, I would say, more in weak hydrogen bonds, CHO bonds, and unsaturated carbonyl compounds, something like this here. Once again, have a look on the Cambridge Structure Database, and you see the difference. Going back here, strong, and here in the case of this weak. The angles 180, 100, no near region, clear region, and the bond lengths between 1.8 to 3, or 2.2, the region 2.2 to 3.0. Well, 100, 180, 2.2, 3. Compared with the other, 160, 180, 20 degree region, not more, and then very short bond lengths, 1.6 to 2. And in this case, 100 to 180, huge range, and 2.3, 2.2 to 3 is a very long distance. Well, in this case, you can see no information about such CHO hydrogen bonds. Okay? Coming to the end, I would say Cambridge Structure Database is a really fascinating database, and I strongly recommend you to use this database for your scientific questions. If you're interested in the current license, no problem, we have a license for the whole university. Please contact me and I will explain you the procedure to get the license, to download the database, and then you can use it offline by yourself. Good luck.